let's look at the first part first. Following quadrilaterals have sides whose lengths are in the ratio of 3 to 5. Are the quadrilaterals congruent? Catherine, it's a yes or no question. Are they congruent? They're congruent. Same size, same shape. Identical twins. Is this shape congruent to this shape? Congruent.
No.
Guys, what does congruent mean?
Same size, same.
Like identical twins, like the exact same figure. Are these two the exact same identical twins, same figure? No, they are not congruent. They are not congruent. Okay, there we go. Why aren't they congruent? They're different sizes. They're different sizes. The ratio is 3 to 5. The ratio is not 3 to 3 or 5 to 5. So they are different sizes. Alea, are the quadrilaterals similar? They're absolutely similar, yes. So we talked about a few minutes ago in the warm-up, there we go. We talked about they are similar if their angles are congruent. Are their angles congruent? That's what those arcs mean. Those arcs mean this one matches this one, this one matches this one matches this one, so on. Their angles are congruent. Are their sides proportional?
No.
Proportional. Yes. Their sides are proportional because they form a beautiful ratio, 3 to 5. So their sides are proportional. So yes, they are similar. And what is the value of x? Ashley? I'm not sure. Okay. So their sides are in a proportion of 3 to 5. So I'm just going to stick a 3 and a 5. One option you have is to write a proportion. You could set up a proportion. You could cross multiply. 3 is to 5 as 6 is to, I don't know why my pen is being so slow. 6 is to x. Goodness. Okay, well there we go. 3 is to 5 as 6 is to x. And you could cross multiply. What is 6 times 5? 30. 30 divided by 3. 10. So that is one way to do it. Another way you could say is, how is 3 related to 6? It's half. It's half of 6. So what number would 5 be half of? 3 times 2 is 6. 5 times 2 is 10. That's another way to think about it, but the proportion is the mathematical way to do it. All right, let's move on to the next one. Dimitri, write a similarity statement for the figures. That just means list the letters in order. That's all that means. I'm ready.
D, C, A, B.
Okay, D, C, A, B. Squiggly, because squiggly means similar, is similar to? Well, wait, if you started with D, D has a right angle, so we need to do the same exact order.
M, L, N, K.
M, L.
N, K.
No, you need to go in order. You can't jump. M, L, K, N. Yep. M, L. Now, if you...
How would DC?
If you... Oh, I assumed he had written them in order. I'm sorry. I assumed bad. Okay. Okay, Dimitri. DC, let's go around. DC. There we go. DCBA is similar to NKLM. That is called a similarity statement. It's listing them in the correct order. Without measuring, what do you know about the corresponding angles? Kendall? Yep. Like angle D and angle N. What do you know about them? They're not similar. What? They're congruent. That's one of the two things we learned yesterday. The angles are congruent. The sides are proportional. Angles are congruent. Sides are proportional. All right. And then finally, scrolling way too much. What do you know about the corresponding sides, Julius? I just said it a second ago. They're not congruent like the angles there. Proportional. Okay, let's move on and do that bottom part. This is a really important part of that practice, okay? Are the following figures similar? Explain how you know. Angles have to be congruent. Sides have to be proportional. So let's check this first one. Number 10A, the first one. I want you to find the missing angles. I want you to find this angle and find this angle and decide if those are similar. Go. Find the missing angles. Add them up and subtract from 180. Lewis M., what's the missing angle on the first one? Did you get either of them?
40.
What? 40, okay. Megan, what's the missing angle on the second one? 60. So, are the following figures similar, class? Figures? Did you do that? I said figures. Figures similar. I'm combining two words today. Okay. Yeah, I am. I'm making mistakes. Come on, are they similar, yes or no? No. They're not similar, and why are they not similar?
They don't have the same
Angles, and then put congruent, and put a slash through it. The angles are not congruent. The angles are not congruent. Therefore, they are automatically not similar. You don't even check the sides. We could care less about the sides because those angles are not congruent. Now, number 2, we've never done, not number 2, part B or whatever. We've never done one like this before. So let's do this one all together. Are the angles congruent?
Yeah.
Yeah, there's arcs all over the place. The angles are congruent. Now we have to check and see if the sides are proportional. And the way you check is you put small over small, medium over medium, large over large. Okay? So what's the smallest number from this first shape? Smallest number. 1. What's the smallest number from this shape? 1.5. Cool. Scratch them out. You used them. All right. Next number in numerical order. 2. Very good. Next number in numerical order. 3. All right. Next number. 2.5. Next number. 3.75. And largest number. 2.6. And 3.9. Now you have to decide, is that a true statement or is it not a true statement? Are they proportional or are they not proportional? And I would just divide. I would divide all of them. Go to your calculator. 1 divided by 1.5. Find out what it is. 2 divided by 3. Find out what it is. 2.5 divided by 3.75. Find out what it is. You get the idea. I'm sounding like a broken record. Can you go to your calculator? Because I was about to call on you next, but you don't have your calculator. Brett, what did you get when you did 1 divided by 1.5? 0.6 repeating. Cool. Nasia, what did you get when you did 2 divided by 3?
0.6 repeating.
Ooh, it's looking good, guys. Ava, what did you get when you did 2.5 divided by 3.75? This one. Can you divide this one, please? And Lewis, can you divide this last one, please? 2.6 divided by 3.9.
0.6.
Repeating? Okay.
Same thing.
Yay! So what do we answer on this question? Yes or no? Are they similar? Yes, they are similar. And if you wanted to, under the Y, you could literally just write this right here. Angles are congruent and sides are proportional. All right, last one. Are the angles congruent?
Yeah.
Does 90 equal 90 equal 90 equal 90?
Yeah.
Okay, now we need to check and see if the sides are proportional. You put small over small, and you put large over large. The smallest one from this rectangle. 2. The smallest one from this rectangle. 1.5. Largest one, 4. Largest one, 3. True or not true? Torin, let me know when you figure it out. True or not true? True! 2 divided by 1.5 is the same as 4 divided by 3. So the last two were yes, they are similar. All right, I will have you turn that in a minute. Let's go ahead and go to our notes for today. Did you pick up these notes when you walked in? Similar polygon notes. If 2 polygons are blank, then their sides are blank. Oh wow, look at all these people that didn't pick up their notes.
See, it's not just me.
to you today. Yeah. It's all on camera. Whoever didn't pick up their notes. It's not your fault. Okay. If we know two polygons are similar, then their sides are proportional. Therefore, we can set up proportions to solve for the missing sides. So fill in the blanks. Let's get on the right side. Similar and proportional are the first two blanks. Similar, proportional. You can set up proportions to solve for missing sides. Very good. Thank you for following along. Right here. We're going to set up proportions. You're going to get used to writing that word down. Proportion. You're going to know how to spell it. Proportion. Okay? So we're going to dive right in. That's really all there is to the lesson. The rest is just examples. Sim is similar to quad. Solve for x. So all we're going to do here is set up a proportion. We're going to say 8 is to 3 as 12 is to x. So the biggest mistake you can make here is you can set it up wrong. If I go from 8 to 3, then I have to go from 12 to x. I can't go backwards. I can't say 8 is to 3 as x is to 12. Can't do that. So if I go from here to here, then I need to go from here to here. I need to be consistent. What do we do next? Cross multiply. That's what we did yesterday. We already laid the foundation. We're good to go. Matt, whenever you're ready. Cross multiply, please.
36.
Yep, 12 times 3 is 36 divided by 8. I think it's ugly. Cool. So we cross multiply and divide. 3 times 12 divided by 8. We have now solved for a missing side. Moving on. Given that the hexagons are similar, solve for x, y, and z. Round to the nearest tenth if you need to round. This can be overwhelming. You're trying to find 3 different things. Yes? That's right. Oh, yeah. It's totally a pentagon. Good catch. Eagle buck for you. Pentagon. Weird. Okay, anyways, so if you're overwhelmed by having to solve for 3 unknowns, then I need you to just focus on one at a time. I need everyone to just find x and ignore all the other ones. Just find x. Now, to find x, what does x go with in this shape? 28. Those go together. We've got to find, it's like finding a key. We've got to find 2 numbers that go together and we have both of them. We can't use this, z and 21. We can't use that because we have an unknown. There we go. 17 and 30 are the ones we're going to use. That's the key. It's the scale factor, but we don't need to find scale factor. So I would say 17 is to 30 as x is to 28. (17) is to 30 as x is to 28. And then you let your calculator do the work. Jeanette, whenever you get it, let me know. So 15.9, because the 6 tells the 8 to bump up. Okay. 15.9.
So technically,
16, but it says to round to the nearest tenth, so we can't put 16.
okay.
Yeah. Okay, now we're going to find y. I do not want you to use x to help you find y. I want you to use the 17 over 30 again. So we're going to use 17 over 30 3 times. 17 is to 30 as 15 is to y. Yep. You need to go the same direction. You need to be consistent. 17 is to 30 as 15 is to y. Cross multiply. That rhymes. Austin, whenever you're ready.
Oh my gosh.
So hard. Your calculator's doing this. Okay.
26.47.
So 26.5. Because nearest tenth is 1 decimal place. Sorry, what was it again?
26.5.
26.
26.5.
26.5. Okay, so y 26.5. Last one. We're going to use trusty old 17 over 30 again. 17 is to 30 as what? Z is to 21. Yep. 17 is to 30 as Z is to 21. Omar, whenever you're ready. 17. 11.9. Sound good to everyone? 17 times 21 divided by 30. Are you okay with cross multiplying? Cross multiply and divide. Okay, moving on from our pentagon problem. All right, the surface of a novel is similar to the surface of the coffee table book. What is the length of the novel? So since we're looking for the length, we're going to assume that 6 is the width automatically. I'm going to let you solve. And I want you to circle your answer. Number 3, everyone solve it. I'm going to walk around and look at your answer. Except for Ashley, who chose to take a nap instead. Maybe she already knows all this. 6 is to 20. Wait. That's the short, and that's the short. 6 does not go with 20. I rotated these guys. 6 is the width. 6 is the width, and 14 is the width. Be careful. Look at the books. Look at them closer. 6 is to 14 as x is to 20. So you need to flip these. If you're going to go 6 is to 14, you need to go x is to 20. You need to go the same way both times. Okay, so flip that. Yeah. Yeah, it doesn't say what's around you, but let's do the nearest 10 again. 6. Yeah, that will work. You switched it, but that's going to give you the same answer. That's awesome. John, what'd you get?
8.6.
8.6. Okay. Corin, is that what you got? 8.6? Yeah. Okay. So the length of this one is 8.6 inches. And when we do have real-world problems, you do need to label, put units on your answer so that I know it's not feet or meters or miles or leap years. It's 8.6 inches. Flip over to the back, please. Triangle bat is similar to triangle mitt. Oh, look, it's baseball season almost. Okay, solve for x. Go. Is anyone brave enough to go write their proportion on the board? It's fun to write on the smartboard. Maybe call you. Oh. Set up a proportion. This is to this as, actually this is to this. You guys, let me give you a hint. There's a couple ways to do this. You're going to have to do Pythagorean theorem one time. You can do it before you do your proportions, or you can do it after you do proportions. 3 goes with 12. Don't you agree? But 4 does not go with x. That's a leg, and that's a hypotenuse. So what I recommend is I would do Pythagorean theorem first. I would find this value, and I would say 3 is to 12 as that value is to x. Everyone can do Pythagorean theorem. You remember that, right? 3 squared plus 4 squared equals our hypotenuse squared. Everyone do it in your calculator. 3 squared plus 4 squared. This is actually a Pythagorean triple, if you remember. Megan. 3 squared plus 4 squared should be 25.
Yeah, 25.
Okay, let's take the square root of 25.
5.
Very good. 25 equals h squared. Take the square root. It's a 3, 4, 5 triangle. Do y'all remember that? Pythagorean triples? 3, 4, 5. Okay, never mind. Just kidding. You can still do Pythagorean theorem if you don't know your triples. Now we can set up a proportion. 3 is to 12 as 5 is to x. If you went the other way, that's fine too. You went the other way, that's fine. You'll get the same answer. Catherine, what do you get? 5 times 12 divided by 3. 20. Very good. X is 20. The hypotenuse of that triangle is 20. Ask me a question.
How are you?
About this problem. Okay, last one? No, second to last one. Second to last one. There we go. The two tablets are similar. What is the perimeter of the larger tablet? It's like an iPad and an iPad mini. I don't know if those are really similar, but maybe yeah.
No, it's like my iPad, my phone.
In your in a Samsung phone?
No.
Yeah, the Note.
Yeah.
Try.
Set up a proportion. Alea, can you set up a proportion for me?
No, I can't.
Just say it out loud. You don't have to come up here.
I can't.
Yes, you can. Okay, what? 10 is to 14 as?
7.
Done. You totally could set up a proportion. 10 is to 14 as 7 is to x. Ashley, when you're ready. 9.8 inches. Are we done? Did you read the problem closely?
No,
Did
which
you
one is
read
the
the
larger?
problem?
The big tablet.
What is the perimeter?
What is the perimeter? Do you know what perimeter means?
All the sides.
Add up all 4 sides. 14 times 2 plus 9.8 times 2. Dimitri. Kendall?
What?
Perimeter. What's the perimeter of the larger tablet? Julius. What's the perimeter of the larger tablet?
I know it.
47.
What?
47.
47?
1.6
0.6. You got it, Dimitri. Good. 47.6. What's the units? Inches. Woo! Last problem of the day. 2 parts. An architect built a house from the blueprint shown. He used a scale of 1 inch equals 8.5 feet. What is the scale factor? We have not done one like this before, so let's do it together. 1 inch equals 8.5 feet. So start off by writing that down. Well, not equals, but I just put a colon for a ratio. Now the problem is, we are not in common units. Inches and feet, those won't cancel. Those are different units. So we actually have to know in our head how many inches are in a foot. How many inches are in a foot?
12.
12. Hopefully everyone knows that. It's a ruler. Think of a ruler. 12. So 1 inch equals, what's 8.5 times 12? 102. Sounds good?
Yeah.
So 1 inch, God bless you, is to 102 inches. Now we've got inches and inches. So what's the scale factor? How much bigger is the real room?
A lot bigger.
How much? 102 times bigger. Because it's 102 to 1. 102 divided by 1. Second over first. Anytime you divide by 1, it's that same number. So it's 102 is our answer. It's our scale factor. It's 102 times bigger. Okay? That's the scale factor. You cannot find scale factor unless you're in the same units. Okay, now let's actually find, here's the little drawing. The bathroom is 3/4 inch by 1/2 inch. And we want to know how big the real bathroom is in the real house. Now you can A, use the scale factor, or B, use a proportion. What do y'all want to do? Proportion? Scale factor?
Scale factor.
Scale factor.
Okay, so just multiply it by 102. What's 3/4 times 102? 3/4 times 102.
Do I have to put that in parentheses?
Yeah, put it in
5
parentheses.
and a 4. No, wait. 25, 25.
76.5. Now that's in inches. Would you ever give the dimensions of a room in inches? I wouldn't. So you need to divide that by 12. 6.375. Let's go with 6. So it's 6 feet by, that's a small bathroom. Woo. 1/2 times, what was our scale factor? 102? 1/2 times 102. 51. Divided by 12. We want to do feet. 51 divided by 12.
4.25.
Oh my goodness, that's the smallest bathroom in history.
A bathroom.
6 by 4. It's a 6 by 4 bathroom. I don't think you're going to fit that tub in there. Okay. It's more like a half bath.
So no tub, just the sink.
Just a sink and a tiny, tiny little toilet. All right, you have your classwork. There was something wrong with number 4 on your worksheet. It says, which of the following proportions proves the triangle is similar? I need you to add the word not to number 4 on your worksheet. We didn't fix it before they were printed.
Which worksheet?
The one I'm about to give you. Today's worksheet.
Can we try out the other worksheet?
You can turn in the other one, yep. Give it to a person in your group and they can bring them all up there.
We go up there.
She doesn't, well, I want you to try the front at home because I want to know if you can do those things. Yeah, you can do that. If you want to check with Tori, you can, but don't just copy it because I want to see if you can do it.